Hello students, welcome to IMS Academy GATE Foundation course on Network Theory subject. So in this particular session, we are going to discuss the basic laws. Regarding the basic laws, this is the third session. So in the previously, we have covered 2 sessions regarding basic laws, and even before that, we have discussed regarding network theory subject in the introduction topic, that is network elements. Regarding the network elements, we have done the 6 sessions, right? So whoever watching very first time regarding the network theory subject foundation course at our IMS GATE Academy YouTube channel, so kindly visit our YouTube channel. In the playlist, just find out regarding network theory subject foundation course, so you people can watch all those lectures in your free time. Okay, so whoever visiting our YouTube channel very first time, so all of you kindly subscribe our YouTube channel and click on the bell icon so that you will be getting instant notifications. Okay, you won't miss even single video in future. Yeah, good evening Matan. Right, so all of you kindly like and share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session, right? So before going to start today's session, I am going to give 2 important updates for all of you. The first important update is regarding our Telegram channel. Okay, so regarding IMS GATE Academy Telegram channel, regarding this particular link already provided in the description of this particular video, right? So say for example, right now one live session is happening in our YouTube channel, right, regarding network theory subject foundation course. Similarly, in future, whenever the upcoming live sessions are happening, all that notifications and updates you will be getting in this particular Telegram channel. And especially during the live class, whatever the faculties are writing on the digital board, this particular notes we will be sharing in the PDF form. Okay, that PDF we will be sharing in this particular channel, right? And similarly, you will be getting the important updates whenever we are conducting seminar or webinar. Similarly, you will be getting the important updates regarding the government job notifications. And one more important thing, on daily basis in this particular Telegram channel, our faculties will provide 1 quiz question per day. Okay, so on like you are getting one opportunity to attempt 1 question on daily basis. Whatever the concept you are having, whatever the knowledge you are having, with that you can attempt that per day question, and right immediately after you are attending the question, you can come to know whether your answer is correct or not. Suppose if your answer is correct, that means excellent. Suppose somehow other you have chosen wrong answer, no problem. The very next day our faculty will provide the solution or explanation for that quiz question. In that way, you can cross check where you have done the mistake. Okay, so you are getting one great opportunity that on daily basis you are learning something new. Okay, so all these benefits you are getting for free of cost. So all of you can join our Telegram channel. It is free for everyone. Okay, and one more important update, here at our IMS GATE Academy we are having live online program for the students who are targeting in the upcoming GATE exams, like in the year 2025 or 2026, right? So for them, we are providing the live online program at our IMS GATE Academy, right? So whoever enrolling for live online program, each and every student is getting the access of 800 plus hours of live online classes. During these live online classes, here all our faculties will discuss each and every concept from the basic level to the application level, and for every concept we will be discussing the practice questions and GATE questions as well. So whoever attending the classes, they are getting the maximum benefit from the classes itself. Okay, but in addition to that, even we are providing for every subject we are providing theory book, and similarly for every subject we are providing the exercise book. Okay, in these exercise books you can find in every chapter there are 3 levels of questions, like level 1, level 2 and level 3, right? So together, like with respect to your branch, GATE EC or GATE electrical, etc. So whatever the exercise books questions you are having, all together you are having 4000 plus practice questions, right? So if you are able to solve these questions, whatever the knowledge you have gained during the classes, okay, so now with the help of these exercise book questions, you are getting the practice and you can check your confidence level. Whatever the knowledge you have received, whether it is up to level or not, whether you have to do further revision, or you will be coming to know in which concepts you are very much strong, in which concepts you need to further revise, etc. In that way, you are getting good command over whatever the concepts you have learned during the classes. And in addition to that, here at our IMS GATE Academy, we are having one special book and unique book, that is 34 plus years GATE question bank. Okay, the specialty of this gate question bank is here based on the wherever required, our faculties have provided more than one possible solution, and even for the typical questions our faculties have provided the video solution as well, right? So you can find out the QR code in the solution section. Just you have to open the QR scanner in the mobile, and then the respective video solution will be played. Okay, so in this way you are getting amazing learning experience, right? Whoever attending the live classes and then practicing the exercise book questions, and even after that whoever solving the gate questions, right, they are getting whatever the knowledge they are getting, it's like multiple folds. Okay, and in fact you will be getting whatever the journey regarding while you are learning all the concepts, etc. While learning you will be enjoying like anything, because the kind of solution that we have provided are like best solutions, and even though those are best solutions, but wherever possibility is there, we have provided more than one solution, right? So with the help of this gate question bank, you can get the very good command, and in fact you will be coming to know how the gate questions are coming to, like what will be the level of the questions and how the questions will be asking in the gate exam and how to solve, etc. You are getting good command with the help of gate question bank while you are solving. And in addition to that, we are providing 130 plus online tests, right? We are having for every chapter one test will be there, that is called chapter test, and similarly for every subject we are having basic subject test and then advanced subject test, and after that we are having multi subject test as well. Okay, so after that we are providing all the mock tests as well. So all those tests together we are having 130 plus various tests, right? And in addition to that, we are providing 12 My Plan sessions. So every student whoever enrolling for our live online program at our institute, all the students are having access of total 12 My Plan sessions. In every month on an average one My Plan session, each and every student they can book the My Plan session with the corresponding mentor, so that they can get the proper guidance and study plan in order to get very good success in the coming GATE exam, right? So whoever interested and whoever having some doubts regarding this live online program, you people can contact to any of these two numbers. Our counselors will discuss more about this particular live online program, and they will clarify all your doubts regarding this particular program, and you people can enroll so that you can get in the upcoming GATE exams, you can get very good ranks, right? I hope all of you will share this valuable information with your friends and juniors, especially for whoever targeting for the GATE exam in the upcoming years, right? Yes. So I hope all of you are eagerly waiting for this session. So let us start. So in the previous session, today I have taken regarding network theory subject foundation course, right? In that previous session, we have discussed variety of GATE questions based on KCL. Okay. So I hope all of you got good command over how to apply the KCL in the given question, right? So now in this particular session, now let us move on to the next basic law, that is KVL, Kirchhoff's voltage law. Okay, right. Say for example, I am considering one simple circuit diagram here. So here I am considering one voltage source Vs, and then I am considering three resistors like R1, R2, R3. Suppose in this given circuit, if already given, suppose the voltage across each and every resistor like V1, V2 and V3. Okay. So now you are having one closed path. You can observe here you are having, whenever you are saying circuit, that means it is having one closed path, right? You can observe whatever the four elements here you are having, all the elements are contained in series. In fact, all the elements together it is forming a loop or closed path, right? So whenever you are having like this, now you can apply KVL around this particular closed path. You can apply KVL around closed path. See, in the previous 2 sessions we have discussed regarding KCL. KCL we can apply at a particular node, even KCL we can apply for a particular network also. Okay, there also we have covered all the variety of questions in the previous 2 sessions. Okay, now coming to the KVL, whenever you want to apply KVL in the given circuit, you should have the closed path. Whenever you are having the closed path, that time you can apply KVL. So if you want, you can consider the direction either in the clockwise, or if you want, you can consider the direction in the anti-clockwise. No problem at all. Okay, in any direction you can consider. Yeah, good evening Amarjit, good evening. So for the time being, I am considering the clockwise. Okay, of course we will be solving some gate questions in this particular session. Okay, based on the requirement, I may consider in the clockwise, or I may consider in the anti-clockwise. Okay, right. So while you are considering, suppose for the timing I am considering the clockwise direction, right. So like suppose example, I am starting from this particular voltage source. Okay, so from where you are starting, okay, we have to start from one particular element and we will be traversing, and in such a way that we are ending at the same point, like that. Okay, but in this clockwise direction or anti-clockwise, when you are considering, okay, so for every voltage across a particular every element, you are having the polarities like plus and minus you are having, right. So say for example, while you are making clockwise direction, suppose for the timing I am considering that ending direction. Suppose for the timing I am considering ending direction, ending polarity. Yeah. So total we are having 4 elements are present. So I am considering the ending polarity. For every element I am considering the ending polarity, or otherwise second polarity. Okay. Minus to plus, plus Vs. Similarly, plus to minus, minus V1. Similarly, plus to minus, minus V2. Similarly, plus to minus, minus V3 is equal 0. So whenever you are considering either clockwise or anti-clockwise, whatever the elements are connected, for every element you are having the voltage, so definitely it will be having the polarities. So you can consider in that entire closed path, you can consider the second polarity for every element, or you can consider starting polarity. Okay, but for the timing I have considered the second polarity. Okay, so from here we are getting Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. So in this closed path, you are having only one supply. Only one supply is there. Okay, so that supply voltage we have kept one side, and whatever the other 3 elements are there, those are nothing but passive elements or resistors. They are absorbing the power, right? So what we have done here, for any closed path, whatever the net supply is there, that should be equal to whatever the elements that are absorbing the power, that resultant voltage sum. Okay, so the net supply should be equal to the net absorbing voltages, like that. Okay, similarly, say for example, whatever the equation 1 here you are having, okay, from this equation 1, okay, from this equation 1, if you are taking minus as common, then what will happen in this entire equation? So here you will be getting minus Vs, then plus V1 plus V2 plus V3 is equal to 0. Suppose whatever the equation 1 you are having, I have taken minus as common, then minus Vs plus V1 plus V2 plus V3, right? So here you are having minus of this entire term. Okay, now you can multiply on both the sides with minus sign, then minus into minus will be plus, and here 0 into minus, anyway you will be getting minus 0. Minus 0 and 0 will be considering as 0. So from here you are going to get minus Vs plus V1 plus V2 plus V3 is equal to 0. So this is one more equation. Okay, here total we are getting 3 equations. Okay, now if you observe earlier, whatever I have considered clockwise direction, right? Suppose instead of second polarity, if you have considered first polarity, then what will happen? Here minus Vs, then plus V1, then plus V2 plus V3 is equal to 0. Like that, you can consider for every element you can consider starting polarity, or for every element you can consider second polarity. But you should not consider it for few elements starting polarity, for few elements second polarity. Not, you should not consider like that. But whatever the closed path you are having, for that entire closed path, you can follow any one convention. Either if you want, if you are comfortable with the second polarity, accordingly you can consider. Or if you are comfortable with the first polarity, accordingly you can consider. No problem. Because ultimately, when you are taking minus as common, from there you are getting this equation. Or similarly, when you multiply this entire equation with minus, you will be getting this equation. Either from equation 1 or 2, we can write equation 3. I hope all of you got the clarity. Yes, very good, Amarjit, very good. So here plus 2 minus means actually whenever you are having the resistors, right? So obviously when we have considered like this direction, that means the current direction is like this, right? So current is flowing from positive terminal to the negative terminal, right? So that means it is absorbing whatever the elements, okay, through which the current enters at positive terminal, that means all those elements are absorbing, whereas from positive terminal the current leaves, that means it is delivering the power like that. Yes, very good, Amarjit. Okay, so I hope all of you got the clarity how to apply KVL for the given circuit or for any closed path. Okay, right. Now with this understanding, all of you just give a try. This is the MCQ question. It is based on theoretical concept. So all of you choose. Since it is MCQ, obviously one option will be correct. All of you read the question and then choices one by one, and you can choose among the given choices which one is correct. I hope all of you can answer this question. So regarding KVL, whatever we have discussed, that definition is there in one choice, and in another option, that is a generalized statement is there. Whether that is correct or not, you can identify. Yes, Amarjit is getting, yeah, one of the option like A. Yes, that option is correct, but for the given question, whether, because you are having one more option like both A and B are correct. Okay, that we have to verify. Okay, so up to now at least one option you got correct, that is true. Okay, so choose the correct option. Choose the correct option regarding KVL, right? In option A, if you see, in any lumped electric circuit, the algebraic sum of voltage drops, around any closed path is equal to 0. So just now whatever we have discussed, right? So that is the based on KVL, the definition of KVL, right? Whenever you are having closed path, there you can consider sum of all the voltage drops, okay, that should be equal to 0. That means here this equation or that equation, no problem. In any order you can consider. Now option B, if you observe, KVL is independent of nature of elements that are present in that closed path. Yes, this is also correct. Here independent of nature of elements. Okay, nature of elements means the types of elements that we have discussed in the earlier sessions, right? Like linear, non-linear, or active, passive, etc. Right? So just you can observe in this given circuit also, if you observe, here you are having the source, active element, whereas resistors are passive elements or absorbing, right? So here you are having active element, here you are having passive elements. Okay. Similarly, it can have like linear, non-linear, or AC source, DC source, etc. Right? So whatever may be the type of elements present in that given circuit or closed path, so for any closed path we can apply the KVL, right? So that's why here KVL is independent of nature of elements that are present in the closed path. Okay, so that means here option A is correct, option B is correct. So like that in option C is there. So that's why we have to choose option C. Option C. So even regarding KCL also we have discussed in the last class, one of the last class. KCL is independent of the nature of elements. Similarly, KVL is also independent of nature of elements that are connected to the in that closed path. Okay, right. Suppose if the same question instead of MCQ, okay, suppose example, here option C you don't have like this, okay. Instead of option C, some other statement is there, okay. Suppose if that is wrong, example. In that case, option A, option B you have to choose, okay. That is the only difference between MCQ and MSQ. MCQ means among the given choices only one option will be correct, whereas MSQ either one option or more than one option can be correct. Yes, very good Amarjit, very good Amarjit, yes, very good. Now with this understanding, all of you give a try. Similar kind of question even we have seen earlier with respect to KCL. So similar question I have given here with respect to KVL. All of you give a try. I hope all of you can answer this question correctly. Yeah, Amarjit, regarding law of conservation of charge, we have discussed with respect to KCL in the last class. Okay, regarding this one, it will be satisfying law of conservation of energy. Law of conservation of energy. Okay, so how KCL is obeys law of conservation of charge, that you can refer in the previous session that I have covered already. So for the timing regarding KVL, let us see. Okay, how it obeys law of conservation of energy. Say for example, what are the equation 3 here we got, this equation I am considering. Okay, Vs equal to V1 plus V2 plus V3. So that equation I am considering now. Vs equal to V1 plus V2 plus V3. And I hope all of you know the basic relation with respect to voltage and energy. So V equal to dW by dQ. V equal to dW by dQ. Just like current is nothing but dQ by dt, in the similar way V equal to dW by dQ, right. So now you can substitute here. In place of voltage, you can use this expression, but wherever suffix you are having, accordingly that suffix you can put for W. Okay. So from here you will be getting dW S by dQ equal to dW1 by dQ. Similarly, you can write other two terms. Okay. Now here on the right hand side, whatever the term you are having, that entire expression we can write like this. So left hand side term I am writing as it is. On the right hand side I am writing like this. Sorry. Can we write like this? Yes. When you have studied regarding differentiation or integration in the mathematics subject, okay, so whenever you are having like this, we can write in this way, or whenever you are having an expression like this, we can write like this, vice versa. Okay. Now on both the sides you can perform the integration, so that integration and differentiation both will get cancelled. From there you are getting Ws is equal to W1 plus W2 plus W3. Yes. So here in any closed path, see, just like law of conservation of energy, whenever you have studied during your physics, okay, physics subject, so the energy neither can be created nor can be destroyed, right? Energy can be transformed from one form to another. In a similar way, here you can observe. So here voltage or potential is nothing but like how much energy you are performing, like in order to bring two charges, right? See, when the potential will exist, whenever, say for example, okay, see, you might be having the standard definitions in your textbook and all, but for the time being, just for variety, I am introducing in another way. Okay, say for example, if you are sitting currently, okay, So you are having one kind of energy. What is that? Say for example, currently all of you are attending this per day class by sitting, right? So since you are sitting now, okay, so what kind of energy you are having? All of you can mention. Similarly, say for example, if you are running, then what kind of energy you are having? All of you can answer. When you are sitting, what kind of energy you are having? When you are running, what kind of energy you are having? Obviously, when you are sitting, that means you are not making any movement, right? So if you are not making any movement, that means it is like static, right? So when you are at rest, that means you are having one kind of energy, that is called potential energy. Similarly, when you are running, that time you are having velocity, right? So that time you are having kinetic energy. Similarly, when the electrons, yes, very good Amarjit, very good, okay. So when the electrons are static, or we can say when the electrons are at rest, they are having one kind of energy, that is called potential energy. That particular phenomena, okay, because of that potential energy, they are getting the voltage. Okay, that particular phenomena of the static electrons or the electrons at rest, that is called voltage. Similarly, when the electrons are moving, they are having kinetic energy. That particular phenomena of moving electrons is nothing but current. So current we will be calling as rate of flow of charge, dq by dt. Similarly, the voltage we are calling it as dw by dq. Okay. So regarding the standard definitions, you might be studying from the textbook just for variety, just in order to understand this basic electrical quantities in the simpler manner. I have given like this approach. Okay. Similarly, the voltage difference or potential difference is nothing but, say for example, in the earlier class also we have discussed, when we are having the resistor, okay, when we are having the resistor, it is having two terminals, right? So this side one terminal is there, this side one terminal is there. Okay, here this terminal node voltage with respect to ground, this terminal node voltage with respect to ground. Okay, so VA, VB you can consider. So if you are taking the difference of those two nodes, that is nothing but VA minus VB, that is nothing but voltage across resistor. So with respect to resistor, voltage across resistor is VR1, or we can say V1 here. That V1 is nothing but here VA, here VB, VA minus VB, like that we can consider. Okay. So in that way we can observe from the given circuit, okay, whether is it voltage across a particular element or voltage difference between 2 points, both are same. Suppose with respect to resistor, here terminal A, terminal B, VA minus VB is nothing but V1, like that. Okay. So here I hope all of you got the clarity. So the KVL obeys law of conservation of energy, law of conservation of energy. So for any closed path, say for example in this circuit or closed path, for this entire circuit only one active element is there, this is supplying the power, right? Whereas the other three elements are absorbing the power. So for any closed path, how much energy, net energy was supplied, the entire net energy should be distributed in other elements that are connected in the given circuit. Okay. So that is the meaning of law of KVL obeys law of conservation of energy, right? Now let us solve the questions based on KVL. Okay, in this particular session we'll discuss variety of gate questions based on KVL. All of you give a try, just like in the previous session I have given the time for every question. In the similar way here also I will be giving some time. All of you give a try, and whatever the answer you are getting correct, you can mention in the chart. So whoever watching this particular session later, so before watching the explanation part, so all of you kindly try whatever the question I am displaying, and you can mention your answer in the comment section. Okay. Yes, very good, Amarjit, very good. Yeah. So here you can observe. So they have given one circuit diagram, simple circuit diagram here you are having, and here we are supposed to calculate the voltage across the current source. Voltage across the current source. Voltage across the current source that they have labeled as V out. Okay, right. So here you can observe, here in this circuit total you are having 3 elements, like 10 volt source is there, 2 ohm resistor is there, 5 ampere current source is there. Only 3 elements are there. Now tell me how these 3 elements are connected. Whatever the 3 elements they have given in the given circuit, how these 3 elements are connected. Ten volt source, 2 ohm resistor, 5 ampere current source, how these 3 are connected. Series or parallel? See, if you want I will give the hint. Tell me how much current is flowing in this branch. Either in this direction or opposite direction, no problem. 0 ampere. Okay, so that means whatever the current 5 ampere is coming here, whatever the 5 ampere current is coming here, the entire 5 ampere is flowing like this. The entire 5 ampere is flowing like this. Now, the entire 5 ampere is coming like this, right? Here 5 ampere is coming, the entire 5 ampere is going like this, that means there is no current flowing like this, right? In any direction you can consider. Okay, since I have considered like here outward, here I am considering like inward, or if I consider here inward, here I will consider outward. Yes, very good, Amarjit. Okay, so since there is no current flowing in this terminal, that means whatever the 3 elements they have given, all the 3 elements are connected in series. In series current will be same. Okay, but in this circuit, because of this 5 ampere current source, the current is flowing like this. Okay, right. Now you can use Ohm's law. Here 5 ampere and then 2 ohm resistor. That means you are getting polarities, voltage polarities plus here minus here. Okay, 5 into 2, that is nothing but 10 volts. 5 into 2 is nothing but 10 volts. Okay, now across 5 ampere, as per the given question, the voltage polarities are plus minus like this. Okay, now in this question you can apply KVL around this closed path in the anti-clockwise. Okay, why I am considering anti-clockwise? Because see, even if you want, you can consider clockwise, no problem at all. Because here for the timing, since current is flowing in this direction, that's why I have considered I am writing the KVL accordingly. Suppose if you want to write in the clockwise, you can write, no problem at all, no problem at all. Okay, suppose I am considering here minus to plus. Okay, just like earlier, I am considering the second polarity. For every element, the voltage polarity second one I am considering. So minus to plus, plus. Sorry. Minus to plus, plus V out. Okay, then plus 2 minus, minus 10, then once again plus 2 minus, minus 10 is equal 0. See, I am repeating once again, for every element I have considered the second polarity. Here plus, here minus, here minus. Okay, now from this equation you are getting V out equal to 20 volts, because minus 10 that is minus 20, when you bring to the right hand side it will become positive. So V out equal to 20 volts. V out equal to 20 volts. So that is there in option D. Option D is the correct answer. Okay. So here for understanding purpose, I have written the KVL equation like this. Okay, but once if you understand that these three elements are continued in series and this 5 ampere current when you have represented like this. Okay, so after that by using Ohm's law we have represented the voltage here. Okay, now instead of writing, see most of the gate questions wherever you require to apply the KVL, of course you can write the KVL equation like this, but what is the answer you are getting? Okay, you can easily get if you are able to visualize the given circuit carefully. Okay, if you are able to align the elements accordingly, then even with the help of that alignment, you are getting the answer quickly. Okay, of course, there also you are applying KVL, but we are doing the calculation simpler manner. Okay, so that approach I am telling now. Now just observe here across the 5 ampere, I have to find the voltage, right? So that means I am keeping the voltage terminals accordingly as it is, plus minus V out. Across the 5 ampere, I have to find the voltage. Now, so that voltage representation I have written as it is V out. Now just observe with respect to another side, that means towards left hand side, whatever the path is there. See here V out is nothing but, say for example, I am labeling this node as A and similarly this node as B. Suppose between the points A and B, as per this given circuit, we are having V out. Now you are having one more path. You are having one more path between the same terminals A and B, right? So here first I am having 10 volt source. 10 volt source I am having, I am keeping as it is. Okay, representation. I am talking about polarities and then voltage. Okay, plus minus 10. Okay. Now by using Ohm's law, here you got 10 volts like this, polarities plus here, minus here. Polarities plus here, minus here. Now whatever this 10 volt here you are having horizontal, for the timing, just keep vertical element like this. Just keep this horizontal resistor in the vertical. Okay, when you are keeping vertical like this, then you will be getting just like this one, plus minus 10 volt. Plus minus 10 volt. Is it clear for everyone? If you are having any doubt, you can ask. Whatever this horizontal representation minus plus you are having, when I kept vertical alignment, you are getting the polarities plus minus. Once if you are able to write like this, that's all. Okay. Now both the elements polarities are same, plus minus plus minus. When you are having like this, that time you can add, that's all. So you will be getting resultant polarities once again same, 10 plus 10, that is nothing but 20 volts, that's all. Suppose if polarities are opposite, that time we can perform the subtraction operation. In this way, with the help of like this calculation, if you are able to do, then damn sure you will be getting correct answer. But whoever write KVL like this, definitely they will be getting correct answer. But whoever, generally they may do silly mistake while they are considering the KVL either clockwise or anti-clockwise. Okay, while they are writing the KVL equation, in general some students may do the silly mistake. Okay, instead of plus they may consider minus, etc. Even for the same question, say for example for one case they may consider minus, one case plus. Because of that you may choose answer as 0. Okay, that kind of silly mistakes in order to avoid, even say for example after solving any question based on KVL like this, if you are having any doubt during the GATE exam whether your answer is correct or not, just follow this approach. With the help of this approach, if you are getting the same answer, definitely that is the correct. Okay, but in fact I am recommending that whoever getting good command after applying KVL, just like the standard equation after writing, okay, if you want to solve the GATE questions based on KVL in less time, better follow this approach. Okay, with the help of this approach, I am saying that here for understanding purpose I have written whatever the data is required, everything I have represented here. But whatever the calculation is there, that calculation you can do on the mind level. And of course, wherever required, you can write on the paper like this direct. And based on that, with the few steps, directly you will get the answer. Okay, right. So with this understanding, now let us proceed to the next question. All of you give it a try. All of you give a try. Here in this question you have to find out the voltage across 3 ohm resistor. Yes, very good Amarjit, very good. Very good. Yeah, option A is the correct one. Very good. See, in this question, they are asking voltage across this 3 ohm resistor, right? So, here when you observe the circuit, okay, here you are having 5 volt source, here you are having 4 volt source, here you are having 2 ohm, and here 3 ohm. And if you closely observe, this 2 ohm resistor and 4 volt, both are connected in parallel. Both are connected in parallel. In parallel, voltage will be same. Whatever the 4 volts here you are having, the same voltage you are having across this 2 ohm resistor, because both are connected in parallel. Okay, once if you observe that these two are connected in parallel and the same voltage you are getting here, now you can apply. Yes, very good Amarjit. If you want, you can apply outer loop, or otherwise, because both are connected in parallel, whatever the voltage here you are having, you can consider here. Okay, now you can apply KVL around this particular closed path. Okay, you can consider clockwise or you can consider anti-clockwise, no problem at all. Okay, right. So for the timing, I am considering clockwise. So here also I am considering second polarity. For every element, I am considering second polarity. Okay, from here I am starting. Okay, minus 2 plus, plus V. Then minus 2 plus, plus 5. Then plus 2 minus, minus 4. Then plus 2 minus, minus 4 is equal to 0. For every element, I have considered the second polarity. Plus, plus, minus, minus, that's all. Okay, so from here, you will be getting here minus 4, that means minus 8, plus 5, minus 8. So from here, you are getting minus 3. From here, you will be getting 3. So voltage across that particular 3 ohm resistor is 3 volts. 3 volts. Okay. Here we have applied KVL like this, and now once again, whatever we have discussed the shortcut, I am explaining once again. With the help of that, we can get the same answer. We can get the same answer. Say for example, here across the 3 ohm resistor we require, right? So just for easy understanding, this 3 ohm resistor I am keeping vertical element. Okay, whatever the 3 ohm resistor horizontal is there, I am keeping vertical. Then the polarities will come plus minus, plus minus. The polarities will come plus minus. Okay, right. Now when I have kept this particular resistor here, okay, so other 3 voltage sources. Okay, here you are having 5 volt, here 4 volt, and here once again 4 volt. Okay, I am just keeping another side. I am just keeping other side. So for the time being, okay, so this resistor I have kept here. Now whatever the 3 elements are there, I am keeping all the elements on the other side in the vertical. Okay, so first I am considering this 4 volt. Okay, since this 4 volt is there, I am keeping as it is. Now whatever the horizontal 4 volt voltage source you are having, keep vertical element. Then once again you are getting same polarities, plus minus 4 volt. Whatever horizontal you are having, keep vertical. Okay, polarities are plus minus. Now when you are bringing this 5 volt source on top of this voltage source, when you are keeping like that, then what will happen? Here whatever the voltage source you are having, when you are keeping vertical, the polarities will become ulta. You are getting minus plus 5 volt. Okay, one second. So here you are getting minus plus 5 volt. Is it clear for everyone? Here first I have represented this 4 volt as it is. I have kept this 4 volt vertical, then polarity is same, plus minus 4 volt. But when I have kept this 5 volt on top of 4 volt, so this plus, you can observe here, this plus are adjacent, plus plus, and then this minus is coming top, that's all. In that way, when you have visualized, okay, now you can observe here in this case, plus minus, that means we can add both the voltages, that means 8 volt, okay, and the other voltage source I am keeping as it is, Now in this case, the polarities are plus minus, but here minus plus. What we can do? We have to subtract, right? Okay. So here in this case, the polarities, say for example, plus minus is there, minus plus is there, you have to perform subtraction, okay, right. So in this case, you can subtract the smaller from larger, okay. 5 volt you can subtract from 8 volt, so that means the resultant polarities you are getting plus minus. Whatever the larger is there, that larger one polarities you are getting. So here 8 minus 5, that is nothing but 3 volts. Suppose if you want to represent in another way, suppose minus plus, suppose this is 8 volt and this is 3 volt, okay. In that case, 8 minus 3 is 5 volt, but there you are getting minus plus, like that. Yeah, Amarjit, Priyanka madam's classes also will come. Okay, actually madam was on leave for last few days, so that is the reason you are unable to see the live sessions. But in this upcoming days, you can get the lectures regarding maths or GA. Okay, so I hope all of you are getting the clarity. So here the polarities are plus minus 3 volt. Yes. So here across the 3 ohm resistor, the polarities as per the given question plus minus V, and the same polarities you are having plus minus. So here you are getting 3 volts. Yes. Okay. In this way, we can, wherever you are supposed to apply KVL, okay, without writing the KVL equation, you can visualize like this. From there, you can get the same answer easily. Okay. Right. So with this understanding, now let us proceed for the next question. This is the gate question which is asked in 97 in EC branch for 1 mark. All of you give it a try. This is a very, very interesting question. This is a very interesting question. All of you give it a try, and what are the answer you are getting, you can mention in the chart. Yeah, Amarjit, just cross check once. All other students also please cross check once. And whoever watching this party session later, so before watching the explanation, all of you kindly try this question and you can mention your answer in the chart. You can mention your answer in the comment section, whoever watching this particular session later. Yeah, this is a very interesting question. That is the reason. Actually, this question is very simple question, direct question, but generally, just like Amarjit, even like whoever attempting like these questions during the GATE exam, most of the students will do the silly mistake. Okay, so because of that silly mistake, whatever the answer you may get, that answer or that value they will give in option A. Okay, because in the exam you will be in hurry mode, right? So because of that, whatever the silly mistake you have done, because of that, whatever the possible answer you are getting, that answer they will keep in option A. Because of that, you may choose that option, right, in the exam as correct. But unfortunately, sometime, okay, if that is not actually correct, then because of that you may be getting negative marking. Okay, but no issue at all, because currently you are learning the subject. Okay, you have done mistake, no problem at all. But here the purpose of this particular foundation course is whatever basics are there in order to become strong on the basics, because in the network theory subject totally you are having 5 chapters, either you are from EC, electrical or instrumentation. For all 3 branches totally you are having 5 chapters, right? Among all the 5 chapters, the first chapter concepts are the basics for all the upcoming chapters, like second chapter, third chapter, whatever it may. So that's why in the foundation course I have selected even from the first chapter few topics I have collected, and from those basics only I am talking more about that, so that whatever the basics you are learning with the help of this series of lectures, damn sure you will not forget any basic concepts that we are covering in this series of lectures. And in fact you will never do even single silly mistake whenever you are applying whatever the concepts you have learned from the foundation course. Okay, right. So this is the most interesting thing. Okay, so just observe here. Here in this question they are asking the voltage across these 2 terminals. Okay, suppose for the timing I am labeling this terminal as A and this terminal is B. Between the terminals A and B they are asking the voltage, right? So here you can observe on the other side, on the right hand side, when you have observed, you are having 2 ampere source is there, 2 ohm resistor is there, and 5 volt source is there. Okay, how these 3 elements are connected? How these 3 elements are connected? So these 3 elements are connected in series. In series, same current will flow. Okay, so here since they have given 2 ampere, the same 2 ampere is flowing in this 2 ohm resistor, the same 2 ampere is flowing in this 5 volt source, like that. Okay, now you can use Ohm's law here. 2 ampere current is flowing and 2 ohm resistor you are having. By using Ohm's law, you are getting 2 into 2, that is nothing but 4 volt. Okay, across this resistor you are having 4 volt. Across this voltage source, they already given 5 volt. Okay, suppose instead of between A and B, okay, instead of between A and B, suppose if they are asking, suppose these 2 nodes I am considering like, suppose this point is same B. Okay, so for the timing I am considering this point is something like C. If they have asked to calculate between the points C and B, then just apply KVL. Okay, just apply KVL here. So here I am considering that plus minus VCB. Okay, so if you want you can write KVL, otherwise whatever the other notation I have told, so that method you can follow. Suppose here you are having plus minus VCB with respect to these 2 terminals, the voltage. Okay, now on the other side let us consider here plus minus 5 volts, and whatever here 4 volt horizontal you are having, let us keep vertical element, then polarities you are getting plus minus 4 volt. Now since these polarities are same, now we can perform addition, plus minus 9 volts. So if they have asked the voltage across C and B, then 9 volts is the correct. Okay, that 9 volt is there in option A, but they are asking with respect to A and B. Now tell me, whether do we know the information regarding the voltage across current source? Yeah, Amarjit, when you are calculating, so here in this case, like if you are drawing the equivalent circuit, suppose example here you are having 2 ampere source, here you are having 2 ohm. suppose in the upcoming chapters, like you will be finding Norton's equivalent or Thevenin's equivalent, etc. So that time when you're doing the equivalent circuit calculation, that time this part of the circuit you can represent as current source, that's all. But here they are not asking that one, no. Okay, that's why we have to consider. Whenever they are asking the calculation with respect to powers or voltage, so we have to consider every element. But whenever you are supposed to find out the equivalent circuits, that time we can reduce. A current source in series with resistor is as good as current source. That means we can say that this resistor is like redundant. Okay, because instead of 2 ohm, you can have 5 ohm, 10 ohm, whatever the resistor value. Irrespective of that, the same current 2 ampere is flowing. So that's why based on that, we can consider that the equivalent circuit as 2 ampere. That is true. But whenever they are asking, say for example here, in this question, if they are asking the power, or if they are asking voltage, or if they are asking, okay, so that time we should not neglect this particular resistor. We should not neglect. Okay, because based on this resistor value, okay, the voltage expression here you are going to get, that may be, okay, that is the reason. But here the most interesting thing and important thing, okay, whatever I have applied KVL here, the same thing most of the students have applied here with respect to this, but that time most of the students have forgot one thing, that they haven't considered the voltage across this particular current source. Then because of that, what are the 9 volts you are getting, that is there in option A. But 9 volt is not the correct one. The reason is, say for example here 2 ampere current source is there. Since we don't have the voltage across it, so I am representing, okay, the voltage polarity is like this. Say for example minus plus, because since there is a current source, okay, so accordingly I have considered the polarities like minus plus, because from positive terminal current leaves. Okay, so say for example the voltage across this current source is V2A. Okay, now just apply KVL by considering this voltage polarities and this current source and this one, that's all. Now when you apply, what you are going to get? Here the polarity is plus minus V, that is with respect to terminals A and B. With respect to terminals A and B. Okay, on the other side, here just now you got plus minus VCB, that is same as 9 volt. 9 volt we got, and then whatever this voltage source you are having, voltage source means notation I am talking, current source only actually we are having, but across the current source what is the voltage notation we are having, polarities. Okay, that notation let us keep vertical, then you are getting polarities plus here, plus you are getting here, and minus is coming top. So that means minus plus. When you are keeping this voltage terminals or polarities vertical alignment, then plus is coming here, minus is coming top, minus plus, then V2A. Minus plus V2A. Now you can observe here polarities are plus minus, here minus plus. That means we have to perform subtraction. But here you are having polarities plus minus, so accordingly I am considering polarities plus minus. So plus minus is having here for 9 volt. So from there I am subtracting the other voltage, that is V2A. So here in this question, since we don't have the information regarding the voltage across current source, so that is the reason we cannot comment. See here, just observe here, the voltage V in the figure is always equal to, they have mentioned always how much you are going to get. Okay, if they have mentioned the voltage across this current source is suppose 0 volt, example, in the given question if they have mentioned 0 volt, then 9 minus 0 is 9, then you can choose option A. Suppose if they have mentioned the voltage across this current source is like 8 volt, then 9 minus 8 is 1 volt, option C you can choose. Similarly, if they have mentioned the voltage across current source is like 4 volt, 9 minus 4 is 5 volt, you can choose option B. But here we don't have any information regarding the voltage across the current source, right? So that is the reason we have to choose option D. Or in other words, we can say that the voltage across A and B terminals is nothing but 9 minus V2A, that depends on the voltage across the current source. Unless otherwise we know the information about the voltage across the current source, we cannot comment how much voltage we are getting. Okay, so this is the most interesting thing. Whenever you are having voltage source, okay, that means you know the voltage value. Because it is producing the constant output, that is voltage. Say for example here in this case 5 volt, so output is 5 volt. But how much current is flowing in this particular voltage source, that is completely based on the network elements that are connected in the given circuit. In this circuit, since 2 ampere is connected here, because of that 2 ampere is coming. Suppose example 4 ampere connected, then accordingly 4 ampere can flow like that. That is a very interesting thing. Yes, very good Amarjit, very good. In this case, data is insufficient. That's why if they mention like in one of the choice like data is insufficient, we can choose that one. But instead of that, they have given like none of the above. So accordingly, we can choose. Because in this question, strictly they have mentioned the voltage across A and B terminals is always equal to. So we cannot comment exactly which value. So that is the reason we have to choose appropriately. So whenever you are having MCQ questions, so in most of the questions you will be getting exactly whatever the value you are supposed to get, but in whichever questions you are unable to get, then accordingly based on the given choices we can choose the whichever option is more appropriate or more relevant as per the given context. Accordingly we can choose. Okay, right. So I hope all of you are getting the clarity. So for this question, option D is the correct one. Yeah, Amarjit, in this case, since you are having 2 ampere current source, okay, because it is producing 2 ampere is the current, right? So since all the elements are connected in series, this 2 ampere is current is flowing in this particular 5 volt source. Okay. Similarly, if instead of 2 ampere, if they have given 4 ampere, then 4 ampere current will flow like that. So that means the conclusion point is very simple. Whenever you are having voltage source, that means we know the voltage, but we don't know the current. Okay. Unless otherwise, the information given, just like here in this particular example, since because of this 2 ampere, we are able to directly know the how much current is flowing. But in general, when you are having voltage source, we know only one information, that is voltage value. Similarly, when you know the current source, that means only one information you are having, that is the current. But the voltage across the current source could be of any value. Similarly, the current flowing through the 5 volt source or any independent voltage source could be of any value based on the other network elements that are connected in the given circuit. Based on that, it can adjust to any other value like that. Okay. So in this 5 volt source, suppose example if the terminal is kept open, okay, then 0 ampere current is flowing. Even in the 5 volt source, even 0 ampere is allowed like that. Okay. If you want more clarity about this particular independent sources with respect to voltage source or current source, you can watch the previous sessions where we have covered with respect to active elements. From that characteristics you will be coming to know, okay, whatever the conclusion points here I have covered. These conclusion points based on the application of those principles only, but there I have discussed with respect to the concept. Now this is the application based on that concept. Okay, I hope it is clear for everyone. So all of you give a try for this question. This is a simple question. I hope all of you can answer. So this is the last question for today's session. All of you give a try, and whatever the answer you are getting, you can mention the chart. Yes, very good Amarjit, very good. So in this question, you are having the circuit diagram like this. We have to calculate the value of the source voltage. Okay, here E value we have to calculate. That is the question. Okay, so just observe here. You are having 2 ampere current is flowing like this. Okay, so here by using Ohm's law, 2 into 6, that means 12 volt. Now if you carefully observe, so in this branch 1 ampere current is coming like this, 1 ampere current is entering, right? Similarly in this branch 2 ampere current is entering. So that means in both the branches the currents are entering. So 2 plus 1, that means 3 ampere. So the resultant current should leave from this particular node. Okay, so this is a question based on KCL and KVL. Okay, so here by using Ohm's law, now we can write the voltage 3 into 6, that means 18 volt. Just you can apply KVL. Okay, either clockwise or anti-clockwise, your wish. Okay, but for the time being, whatever the shortcut notation I have discussed, let us follow same. Here I am considering the voltage polarity is plus minus C. This is with respect to these two terminals, right? So here you are having the terminals, between these two terminals you are having voltage source C. Okay, right. So here you can observe on the other side, here you are having plus minus 18, I am representing as it is, plus minus 18. Okay, now whatever here voltage polarities you are having, I am keeping vertical, then you will be getting plus minus 12. Okay, yes, very good Amarjit. So here in this example, both the polarities are having, you can observe plus minus. Whenever you are having like this same polarities, then you can add, that's all. Plus minus 18 plus 12, that means 30 volts. So E is nothing but 30 volts. Whenever you are having polarities are opposite, you can subtract. Whenever polarities are same, you can add, that's all. So that means for this question, option C is the correct one. Okay, so in this particular session, we have discussed regarding KVL, and then we have discussed variety of gate questions. I hope all of you got the good command how to apply regarding the KVL when you are solving any network theory question. Okay, so for the time being, I am stopping here. So we'll meet you all in the next week. On coming Tuesday, we are having one more session based on basic laws. This is the last session regarding network theory subject foundation course based on the basic laws. Okay, so in that session, we will be discussing further few typical questions. In this particular session, I have covered the basic questions and simple questions, but in that particular session, I will be covering even some typical questions. Okay, we'll solve based on the KVL those typical questions, and then whatever some conclusion points are there, okay, with respect to sources. Okay, since we have discussed KCL and KVL, with respect to that, let us discuss the equivalent circuits with respect to sources as well. Okay, right. Yeah, Amarjit, so as of now, you can just check in your free time. If any upcoming YouTube live sessions are there, you can just check in our YouTube channel, so that from there you will be getting the idea. But regarding network theory subject, so the next session will be there in the coming Tuesday. Okay, so meanwhile, if there is no other session planned, in your free time, just you can watch the previous lectures of network theory subject regarding foundation course. Okay, so this is the, like today, whatever currently I have taken, this is the 9th session. So that means total you are having 9 sessions you can observe in the playlist. So whatever the, since you attended 8th session also today, so whatever the 7 sessions happened earlier, okay, if you have missed any of the session, you can watch those sessions in your free time. Okay, right. Yeah, so once again, whatever the 2 updates I have given in the beginning, once again I am repeating. So whoever not yet joined our Telegram channel, so kindly join our Telegram channel. It is free for everyone. Regarding the link already provided in the description of this particular video. Okay. Similarly, one more important update regarding live online program. Whoever targeting for 25 or 26, okay, you people can contact to any of these 2 numbers. Our counselors will discuss in detail about our live online program. So whoever enrolling at our institute, okay, they can get maximum benefit. They can prepare thoroughly, because we are providing each and everything whatever required for the students whoever targeting for the upcoming GATE exams. Okay, so all these features you are having, so all of you can contact to any of these 2 numbers. Our counselors will discuss in detail. Okay. Yeah, thank you everyone. So whoever not yet liked this particular video, so click on the like button and share this video link with all of your friends. And whoever not yet subscribed up to now, you can kindly subscribe our YouTube channel. We'll meet you all in the next session. Thank you everyone.